Morning, Mr. Lishman is here. We are finally starting calculus. Hey guys, are you with me? Are you with me?
Yes, sir.
Okay. So, calculus, very interesting topic. Mainly, obviously, it has a little bit difficulty, but it's an interesting concept. I think once you understand the concept, then everything goes pretty easy. And you can understand it. Like, unlike the cubic functions we just did now, the cubic polynomials, which are really difficult to understand, calculus we should. Okay? So we start with something very simple, guys. A straight line. Okay? It goes to these 2 points. 1, 2, 3, 4. What's the gradient? How do we calculate gradient?
Formula.
It's what, sorry? Y over x or delta y, right? Delta y over delta x. Delta really means the difference, right? It's the difference between these two y's divided by the difference of these two x. We always have the difference, the delta y at the top. So what is the difference in the y? It's how do we find difference? We do 4 minus 2. And difference in the x is 3 minus 1. Okay, so I chose easy numbers, we're getting 1. Right? So that's a gradient. Okay? But when I say gradient, what does gradient mean? Okay, we calculated it, but what does it mean? It's the steepness, it's the slope, okay? There's a certain slope here. You can imagine a little person walking, okay? Right? The bigger the gradient, the steeper it is. Are we happy with that? Okay, now I'm just going to add to it another graph. Can we see it here? We can. And I'll use the parabola. Does it cross? No. Okay, so we're going to work with a parabola and we're going to choose 2 points. Okay? The points are 2, 2 and 4, 10. Okay, so we again have 2 points. You know what? I'll just pause. I'm going to make it a bit bigger. I need to make that picture bigger. So made it a little bit bigger. And we have another graph. Maybe I'll use the green. Let's see what that looks like. Is it strong enough? Nah, it's not going to show well. Let's use red. Okay? So I drew a parabola now. And then I drew a straight line through these 2 points. And what I'm asking is, what is your average gradient between those 2 points? Okay? If I ask the average gradient between these 2 points, how do I calculate it?
You have to use the formula.
The same. Okay? So it's delta y over delta x. Okay, I'll do it for you. I know you can do it. 10. Just don't forget to always do the difference in the y first. Okay? And this time we're getting 8 divided by 2 is 4. Okay? Now, my question is, why here I just called the gradient when it was a straight line, and here I call it average gradient between these 2 points? Yes, sorry. I know, it's not a hand. Okay? Let's see if you get some answers. Mark's saying the reason why I use the word average gradient is that here it's not a straight line. Okay, yes, I drew that straight line. Maybe I shouldn't have. Okay, well I should, because just to give you an idea. The gradient that I calculated, this 4 is the gradient of this straight line. But if I ask if I want to calculate the gradient of a parabola, I can't really calculate the gradient because it's a curve. Right? You know, Eugene told us what is gradient is the steepness. Okay? So the steepness here, if I'm walking here and if I'm walking there, the steepness is everywhere the same. But on a curve, okay, when I'm starting my walk, the gradient, the actual gradient, okay, this is the actual gradient, is actually less the gradient of the red line. If I walk around here, the gradient is, the gradient here right now is less the gradient of the red line. Okay? Yeah? When I'm halfway through or midway, then the gradient is pretty much the same as the red line. It's parallel. But when I'm at the top, towards the end, the gradient that I'm actually walking is more than the red line. So I can't calculate the gradient at a specific point. What I can do is calculate the average gradient. Does that make sense? Yeah, I'll just pause here. So guys, I'm not really telling you much new. all I'm saying is that when I have a straight line, yeah, I use that formula to calculate the gradient. When I have a curvy line, then I'm using the same formula, but now to calculate the average, let me write it down here. Now I can only calculate the average gradient, okay? And the average gradient is the same as this, but instead of calling it y, I'm going to call it f of x, right? Because I can use the curve, this curve as f of x. So it's going to be f of x2 minus f of x1 divided by x2 minus x1. Guys, this formula is the same. Okay? You see, what is delta x? It's x2 minus x1. What is y1 minus y2? It's the value of the function x2 minus the value of the function of f in x1. That's the same thing as y2 minus y1 divided by x2 minus x1. It's exactly the same.
Yeah.
Okay? The only extra information I've given you so far is that to calculate the actual gradient, I can only really do it in a straight line. Anytime it's not straight, all I'm doing is calculating the average gradient. We happy with that? Okay, let's pause.
Yes.
Right, so let's move on. Okay, so we understand at this point we can only calculate average gradient. But actually, I can say that maybe the whole thing of calculus is to learn how to calculate not just average gradient, but the exact gradient at specific points. Maybe that's probably a way I can explain what's calculus about. Okay? Let's start with a really easy curve. Probably the easiest curve that we know. F of x equals x squared. It's a parabola. Okay? It goes through 0, 0, and it goes through a point 1. What will be the y value? When x is 1, what will y be? 1. When x is 2, what will y be?
2.
No.
4.
Thank you. Okay? You put 2 squared is 4. Okay, so it'll go through these points 1, 1 and 2, 4. I'm going to write them like this. 1, 1. Nah, that's not good. 1, 1, 2, 4. Okay? Now, if I ask what's the average gradient between these 2 points, I can just do it, no problem, using that function. I'll do 4 minus 1, which is 3, divided by 2 minus 1, which is 1, so 3 divided by 1 is 1, right? So the average grade between these 2 points is, what was it, 3. And that's a question that they can ask. This is an easy question. But I really want, I really want the gradient here. Okay? I'm a little person walking here and I want to know the gradient here, not the average gradient. I want the gradient here.
Yeah.
Question, what can I do?
Oh, but it's 2.
So how are we going to find the exact gradient here? I'm going to draw that here with a blue line. Okay? Eugene already said it's the tangent, isn't it? So if I've got, basically I'm going to have this point. Now that's the point where I want the gradient. I don't want the gradient here. Okay? So if I choose that point, that's going to give me this gradient, which is not too far, but it's not the same. Maybe I should choose another point. Maybe not x equal 2. Because to calculate gradient, I need 2 points. I always need 2 points. Okay? x1 and x2. So what other points can I choose instead of 2? That will give me a closer value for the average, for the gradient. Should I choose x equal 3? Is that going to give me a more accurate? Sorry? No. So which x can I use? Give me an example. Half. So really half is going to move to the other side. 1.5, yeah. Okay? So if I, instead of 2, I'm going to choose the point 1.5. Okay? You can see that if I draw that, then again, I probably didn't draw it large enough, but you can see that the average gradient is going to get close to that blue line. Right? Right? Do we know a point maybe which will even be closer than 1.5?
1.2.
1.2, it will be even better, right?
Yeah.
And even better than 1.2?
1.25.
1.25?
1.1.
1.1. Okay? Basically, what you want to do, what other points, what do you want this point to be? Very, very close to 1. The closer I get to 1, okay, let's say I get 1.0000001, one, okay, the closer I get to 1, the average gradient I'm going to work out will get closer and closer to the tangent that Eugene was speaking about, okay? So what I'm going to do, because I can't really draw it very closely together, I will say, okay, look, what I'm going to do is I'm going to choose a point H. And I'm going to say, guys, H is very, very close to 1. This is how we say in maths, H is very, very close to 1. Okay? Well, we add something else, but for now, let's just use this, okay? So I'm using H that is very, very close to what? 1.0000000000000000001, okay? And then I'm going to calculate the gradient, okay? So let's just for now use H and just remember in the back of my mind that it's extremely close to 1, okay? So in this case, your average gradient, okay, is going to be, I'm using that, f of what is x2? The x2 is h, right? So f of h minus f of, what's the other point? What is x1 equal to? 1, okay? So that's your x2 and that's your x1 divided by x2 minus x1, so h minus 1. Are we happy with that so far? Okay, except that actually I didn't use what they said, so sorry, I'm going to backtrack. Okay, we can use that, but it's better we use what they said. Okay. Okay, so instead of saying that h is very, very, very close to 1, what we're going to say is this is basically h plus 1. Okay? And then in this case, what is h very close to?
2. No.
Okay? I want this point needs to be as close to 1 as well, right? Yeah? We agreed on that. So this point needs to be as close to point. We need to do 1.00001, okay? So let's call it h plus 1. In this case, h is a very, very small number. In other words, what is h close to? 0. Okay? So we could have done it the way I did it, but
H is 0.
h is like
The whole value is
yes.
not 0.
Yeah, the whole value is almost 1.
Yeah.
But h is very, very close. H is basically the extra bit that we added here. This thing is h. Okay? 1, and then I'm adding a tiny little bit h, so that means here it's h plus 1. Okay? Alright, so now I need to change a little bit. Okay, so this is f not of h, this is f of h plus 1. This is f of 1. And now I've got, and this is why they did it, this is h plus 1, that's your x here, minus 1. Yeah, that will be much better. Are we happy with this? I'll just pause just to make sure you're still with me. Redraw things on the graph. If the x1 is 1, the x2 is h plus 1, basically a tiny little extra to the h1, then we can write down, okay, the f of this value of x is f of h plus 1, and the value, what is this 1, is basically f of 1, okay? And then to calculate the average gradient, as we always do, we do the difference in the f divided by difference in the x's. Okay. Now, let's start with the denominator. What is h plus 1 minus 1? H. H. Okay, as the English say. H. H. As you say it. Okay? Now I need to use what I know about the function. Okay? Let's start again with this one. What is f of 1? You already told me. If x is equal 1, what is f equal to? Or the y?
1.
1. Okay, 1 squared is 1. Okay, what about if h equal, or x equal h plus 1? How do I know what is the value of y? What should I do? H plus 1, and what should I do to that? Square. Because that's what this function, that machine, remember we learned about machines, okay? You put in x, it spits out x squared. You put in 1, it gives you 1. You put 2, it gives you 4. You put h plus 1, you get h plus 1 squared. Okay? Right, now we just have a little bit of algebra, okay? Opening h plus 1. What is opening h plus 1 equal to? I hope you guys know that by heart. H squared plus 2h plus 1 minus 1. Look at this is pretty good. Okay? Right, so the 1 minus 1 cancel. Okay? We're getting h squared plus 2h over h. Okay, what can we do now? Factorize an h, right? So it's going to be an h. So we're going to have in the bracket, what are we going to have in the bracket?
H plus 2.
H plus 2, you're right. Divided by? H, okay. I need some new space. Let me just clear some space. Over here. So we can't, what are we doing now? You tell me. Cross cancelling the h. So in other words, the average gradient, okay, is equal to h plus 2. But now, I gotta remember, what do we know about this h? It's very small. You know, I can't say it's 0. You know why I can't say it's 0?
It has to be bigger than 1.
No. It will be definitely smaller than 1. But what's the problem if I say it's equal to 0?
It's undefined.
It's undefined. So I can't say that h is 0. But I can say it's a tiny number. It's almost 0. It's the word we use in calculus. It's infinitesimally. This is the word that goes infinitesimally. It's as close as possible you can think to 0, but it's not 0 because then we're undefined.
Exactly, so then it's bigger than 1.
No, 0,1 is.
Yeah, I know, but the whole value of
The h plus 1 is larger than 100%. Okay? But we know that h is very close to 0. Now I'm going to do it in the more mathematical way. Okay? Instead of just writing h closer to 0, what we say, we take the limit, lim, the limit, okay, where h approaches 0. This is a mathematical way to say, listen, h is not 0, okay, but but it is as close as possible. So the average gradient, okay, the gradient, okay, h plus 2, when h is very close to 0, I don't have a 0 equal here. So what would I get h plus 2? If h is as close possible to 0, what is h plus 2 equal to?
2.
Correct. And that's the answer, guys. The gradient here, that gradient that I told you before, that there's no way you can calculate, the actual gradient on that point is equal to 2. And we calculate it by what is called first principles. So I'm going to pause here, see any problems, and then I'll write it in a neat way so we can start solving problems. Before I give you like a formula of how to calculate exact gradients, let's just do one more example in the same way, and then from there, hopefully you'll be more comfortable if I give you a formula. So I've got another parabola, 2x squared minus 3, and what I'm interested is the exact gradient on when x is equal to 2. So just like Eugene said, and he's becoming another sleeping giant, I know this, what is it? It's like a term 1 thing, it's a water polo thing, isn't it? Okay, come on, Eugene, I need you back. Okay? So I want the gradient of the tangent basically to the curve at when x is equal to 2. Okay? Just to get warmed up, what is the y here? Just so we know. Five. Great. We put 2 squared times 2, 8 minus 3, 5. Great. Just for fun. Now, I want that gradient of that straight line. Okay, I'm going to erase it now. Okay. So what I'm going to do, I'm going to choose another point on the curve. Okay, I'm going to draw it far away just so we can see it, but it's not really far away. It's actually as close as possible. It's like here. But if I draw it there, I won't be able to see it. So if this is x, what will the value of x, sorry, if this is, the x value is 2, what will be the value of the x here? 2 plus h. Okay? And I remember, right, already that in this limit, what is h approaches? What is h?
0.
It's not equal 0, but we said another word, another lingo from calculus is it approaches 0. It's as close as possible. Okay, right. What do we have to do now?
Now Now to use the
Nothing.
formula.
Okay, but before we even do the formula, I'm just going to do it. I know it's not very neat. Let's find, well, actually, let's just do the formula. Let's just do the formula. So your gradient, okay, the exact gradient, I'll call it the exact gradient. Okay, before we start the exam, let's call it average gradient. First average gradient, all I gotta do is find, use, you know, f of x2 minus f of x1 divided by x2 minus x1. Okay, that's the general formula. But now I know what x1 and I know what x2. And if I sub these here, I'll be able to get the f of x1 and f of x2. So starting with x2. What is x2 equal? The one on the right. We wrote it there. It's on the graph. What is the x2? 2 plus h.
Yeah.
Okay. What is the x1?
-2.
So it's minus 2. Okay, it's 2, but because I've got x2 minus x1, it's minus 2. So denominator is easy. Okay. Now I've got fx2 minus f of x1. Let's start with f of x1. We already did it. What is the f of the first value?
Yeah.
5. Okay? It's 5. Okay? We've calculated. Okay? Now what do I have to put here? Okay? I have to put f of x plus or 2 plus h, right? Okay? I'll sub it now. I just did a little half a mini step here. Okay? Now I'm going to sub it here. Let's sort out the denominator. What do I have in the denominator? It's always going to, like these numbers are going to cancel. We're always going to have an h there. Okay? Right. Now we got to sub it there. So we're going to have 2 times. What should I write? 2 times. What is x equal to? 2 plus h. So?
Wait.
You sub
We
this.
sub that, yeah.
So tell me what to write. Don't solve it, just tell me what to write. We'll do it next. 2 plus h. Guys, you're not getting it. Okay? What is x equal here? What is x equal to?
2 plus h.
So we just sub 2 plus h.
Yeah.
So it's going
So
to be
it's
2 times 2 plus h
Square.
squared
Minus 3.
minus 3. You're just subbing x plus 2 plus h. Okay? And then don't forget, we still need to minus 5. Okay? Right, we start opening. Start opening. 2 times. Okay. We need to remember these formulas. 4 plus 4h plus h squared minus 8. I'm gonna,
Minus 8.
Oh. yeah, put brackets there. Minus it, minus 3, minus 5.
Okay.
Divided by h, don't forget. Equal. Okay, we need to start opening. So 8 plus 8h plus 2h squared minus 8, not minus 16, he was out of it. Divided by h. This is always going to cancel. We're always going to cancel those two things. So we're going to have 8h plus 2h squared divided by h. Okay, guys?
I take 2
Now, the same. Yes, what do we take out?
2h.
So we're going to take 2h. I'm going to write it down here. 2h. So we're going to have, what do we have here?
2h. So you're going to have 4
4 plus
plus
h
h.
divided by h. Okay. What am I going to have here now?
It's going to be h.
No, the h cancels.
Yeah.
Oh, 2.
So 2. So, okay, so let's do it in 2 stages. We shouldn't really have taken 2 out, to be honest. Okay? And that's now open it. How much do I get?
You get 8 plus 2h.
8 plus 2h. Okay.
Wait, so that isn't 2h divided by h?
2h.
Divided by h is h.
Okay, let's just pause here. Okay. After I subbed everything, Shilali, Simon, please stay with me. After I subbed everything, always cancel that h in the bottom. We have to cancel that h at the bottom because h is a tiny little number. We can't have a tiny number at the bottom. So after we cancel it, what do we have to remember? We have to remember, unfortunately I erased it. Limit. What about the limit? H approaches
0.
0. Okay, so I'll write it again. Yeah? This was the average gradient. Okay, give me an h, I'll get the average gradient. If I want the exact gradient, then I'm going to write down, okay? It's going to be basically 8 plus 2h, but in the limit that h approaches 0. And what will be the answer then? If h approaches 0.
It's 8.
It's 8. And that's the answer. Okay? The grade, did I erase the graph? Oh my goodness. Okay? Okay? The gradient of this graph at the point, what is the point? X equal 2. The gradient is 8. Isn't that amazing? We can actually calculate exact gradient on a slope with the power of calculus. It's
what is the formula?
the way of the future.
Yeah.